In this video, we will see queuing theory. Queuing theory is the mathematical study of waiting lines or queues. The theory enables mathematical analysis of several related processes. Waiting in the queue is a common phenomenon of life. Because of lack of adequate facility cause waiting lines of customers. And here in this graph, along the x-axis I have taken level of services, and along the y-axis I have taken cost. Here this line shows cost of providing services. Again this curve line shows cost of waiting is also involved in queuing models and queuing theory, and this dotted curve line shows total cost. Manager of such kind of services is concerned about minimizing the cost or optimizing the cost. So queuing theory is regarding the cost of waiting and cost of providing services. Whenever the services are provided, queues are formed and cost of waiting is involved. If the level of services are increased, cost of providing service also increase. Here see, the level of services are increased, so cost of providing services also increases. But what is happening here? Cost of waiting will decrease. Cost of waiting will decrease. But the manager who is taking care of such kind of facility is concerned about this total cost. So total cost will decrease up to certain level of services, and then afterward it starts what? Increasing. The level of service where the total cost is minimum. Total cost is minimum, and this is known as this level is known as optimum level, and a manager should always try to provide optimum level of services. So this all are concerned with the queuing theory. Means there are level of and different types of costs are involved, and manager or service in charge should take care of this thing, that how the total cost should minimize, what optimum level of services should be provided. There are different models of queuing theory. First one, that is single server, single queue, where single queue are formed and only single server is available. Another case is of multiple server. There are so many server and single queue are formed. Here we will see that population people who are in need of services are arriving, and this they are waiting in the queue for getting the services, and this shows the serve customers who are coming out of the system. So from here to here, this forms the system, queuing system. Some of the queuing problem examples we will see here. That problem, first one is determining number of attendants required at a petrol station and customers automobile vehicles. Service facilities, petrol station attendant. Second one, scheduling of patients in clinic. Customers would be patients and service facilities doctors. Third one, determining the number of runways at an airport. Customers, aircraft and service facilities available runways. Fourth one, determining the size of parking lot. Customers, automobiles and service facility parking spaces. Likewise, fifth one, determining the service rate for a harbor. Customers, ships and service facility harbor. Here we will see the arrival pattern of customers. Customer arrive in scheduled or random fashion. The duration between each customer's arrival is known as inter-arrival time. We assume it to follow Poisson distribution. The arrival pattern of customer follow Poisson distribution. Rather, service pattern, providing service to customers, number of servers and speed of service to be considered. The time taken by a server to service a customer is known as service time. It is represented by exponential distribution. So arrival pattern follow Poisson distribution and service pattern is represented by exponential distribution. Certain customers' behavior have been observed when they come in queue. First one is barking. Barking means when a customer leaves the queue because it is too long. Means queue is too long or customer has no time to wait or there is no space to stand. Because of such kind of reason, if customer leaves the queue, this is known as barking. Second one is reneging. When a customer leaves the queue because of his impatience. So when customer becomes impatient standing in a queue and because of that he leaves the queue, that is known as reneging. And third one is jockeying. When a customer shifts from one queue to another, that is known as jockeying. So to solve the numerical problem related to queuing theory, there are certain formula we need to know. First one here, lambda, which means mean arrival rate, or it is also known as average number of customers arriving per unit time. So lambda denotes average number of customers arriving per unit time. Mu denotes mean service rate or average number of customers served per unit time. Rho denotes utilization factor. Traffic intensity, probability that the service facility is busy, which means probability that there is at least one customer in the system, which is equal to lambda divided by mu. So rho equal to lambda divided by mu. Next formula, probability that the service facility is idle, means there is no one in the system, denoted by P subscript 0 equal to 1 minus rho equal to 1 minus lambda by mu. Means we are keeping at the place of rho lambda by mu. Fifth one, probability that there are n units, that is customers, in the system, that is being served plus waiting in queue. So Pn equal to P0 under bracket lambda by mu power n. 6. Average waiting time of customers in the system, that is waiting time in queue plus service time. We denote it with WS, W subscript S equal to 1 by mu minus lambda. Next, average waiting time of customers in the queue. We denote it with W subscript Q equal to lambda by mu multiplied by 1 by mu minus lambda, which may be equal to lambda by mu into under bracket mu minus lambda. Next one is average number of customers in the system, that is system length equal to L subscript S. Means what? System length equal to row divided by 1 minus row, which equal to lambda divided by mu minus lambda. The next, average number of customers in the queue, that is queue length, L subscript Q equal to row square divided by 1 minus row equal to lambda square divided by mu under bracket mu minus lambda. So these are the formula. With the help of this formula, we will solve the queuing theory numerical problem.